So we got 2 divided by 8. So that's 0.25 as a decimal. But we got to remember, converting back and forth between decimal and percents requires that 2 decimal point shift. So to make this a percent, we got to go 1, 2 hops. Okay? Makes sense? Do this on the next one. All right, so here's where we run into one where we're really going to have to sort these because of the fact that we're essentially going backwards from that last question. We got to find the dividing line for a particular percentile, which is a fancy word for percent. All right. Let's see if I can get this to work out. I don't know why this thing is... Oh, it's not going to work. I don't know why sometimes it seems to work and sometimes it doesn't. I did it last night. Well, I'll tell you what. I want to go ahead and just save that. And it does that crazy thing. All right. So I'm just going to save it and import it into my little whiteboard thing. All right, so we want to find the 25th and the 90th percentiles. So we need to have the data ordered. I want to ask for your help on this because this is really a cumbersome thing. Because what I like to do is I like to strike them out as I go just to make it, and then I got to come back down here, which means that I lose a place on here, but I should be able to open it back up. So the lowest value looks to be 84. And then it looks like the next value is 157, the one that's blued out. And then the next one is 204. So let me go ahead and strike those out. All right, so what would come next? 248 looks to be. Looks like that one. And 315. Let me know if you see anything that would indicate differently. Oops. There we go. All right, so 248 and 315. and then 338. All right. So what's next? Let's see. All right. So it looks like the next one is going to be 405. In real life, if you're doing this, you could easily sort it with some kind of a spreadsheet, or there's plenty of other programs to do that. But since you're doing this test-wise and you're locked down, we're just going to do it as if we were doing it on paper. Was it 402 or 405? I lost me. 405. 405 and then 452. 472. 495. So 405. 452. 472. And then 495. Make sure I hadn't got anything that's not in the fours yet. So it looks like I'm on track. So now let's look at the 5 and the 6s. So 580, 542, and 586. And then let's see if we can jump to all the 6s. 609. 609. I hit some key that. Okay. So 452. 580. Oops, not that one. Checking at the wrong thing. 609. And then we got a 653. And a 676. So 653. 676. 743. 790. And I think this is all of them. All right, so how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 of them, so it looks like we got them all. That's important. You can't leave any of them out, because for this small of a data set, it's going to make a lot of difference. Now, to find what we're going to do, we're going to take 0.25 That's the decimal times 18, which is the n, or number of pieces of data, which gives us
4.50.
4.5. Now, because we need it to be a whole number because we're looking at for the position. So 1, 2, 3, 4, 5. Okay, so what that means is right here, when we get to 315, that means then we've got it broken down into quarters. Now, since you've got, now if you had 100 values, it would come out to be exact because at 100 values, yeah, everything is going to be 1%, so you can get it more exact. But with this, with 315, if we went down to the fourth position, we're not going to be at the 25th yet. We would be like 23rd or something like that. So in order to get to the 25th percentile, we got to get past that fourth position and in the fifth position to make sure we get past it. Now, it's very similar on this for the 75th. Well, it's not very similar. The only thing we're going to change is that 0.9. All right. So 0.9 is the 90th. So 16.2.
So, Mr. Cruz,
Mm-hmm.
for the 25th percentile, what would we put as the answer in the line?
Right here. 315. See? 1,
315.
2,
Yeah.
3, 4, 5. See it?
So the answer would be 315. Okay.
Yeah, the fifth position. The fifth position tells you where it's at, but you got to go over there and look at it. It's the same kind of a situation as with the median. You're looking at position. And it's just the last one. I'm sorry, the second to last one. Because remember, there's 18 of them. So here's the there's the 25th, and then this is the 90th. Okay. Any questions about that? Now, the only thing that's different, when you're doing the median, you can kind of do it the same way. But if you get in between two, you gotta add up the two middle two and divide by 2. Just how that's handled. So this was a 315, and then this was 11. Oh no, 790. There we go. All right, so now we're still dealing with percents, but we're dealing with them from another aspect. What we're dealing with here is that empirical rule. All right. Remember this empirical rule? This is not the one that that our book uses, but I like this one because it's nice and colorful. So it gives 3 bits of information. That within 1 standard deviation of the mean, remember the mean is right smack dab in the middle. In other words, we go over 1 standard deviation plus, 1 minus, and we got 68%. If we go over 2, we got 95%. And then if we go over 3, we got 99.7. So we can use that to tell us what to do with this. Now, you can
quick question. On the last one for the percentiles, when it's not an integer, do you always round up to the next number?
You always got to round up, because if you were to round it down to 4, what is it that I had on there? Tell me what happens. And let me just show you. So 16.2. So let's just say we did 16. Round it down. All right. So in other words, you go to 743 instead of 790.
Okay.
Watch what happens. I'm sorry. 16 divided by hold on. I have to go ahead and divide. See, you're not at 90 there. You're at 80. Well, if you round it off, you'd be at 89.
Okay, thank you.
That's why you bump up. You got to make sure you get past it. So, like I said, now if you put 19 there, it wasn't 19, it was 17. So you're essentially going backwards from what we did in that last problem. It was 17 divided by 18. I don't know what I'm saying. Say 0.94. So at that point, you're into the 94th percentile. As I had said, if you had 100 values here, then you would be able to be exact. So what you're doing to compensate is you're bumping up to the next one to make sure you're past that point.
Okay, I understand.
Because if you stay down here at the 16th one instead of bumping up to the 17th, then you're only at 89%. All right, so we looked at that empirical rule. Now, you can kind of do this as an eyeball and guess, but they're going to make you calculate it out. Remember, if you're way out where there's hardly anything left on the end, in other words, as a matter of fact, the Math 203 book that we use they're big on using this thing called almost all instead of saying 99.7. They do eventually get to it, but in the earlier chapters of the book, they say almost all, which 99.7 is almost all. But you've just got just a little tiny piece on there, on either side. And it looks to be that that's what that is, that's 3 standard deviations. But let's go through with this. Now, right smack in the middle is your main part of your hump, which should be the mean. They give you that right there. So we can put that in right away. All right, that's the mean. That's what V is. Smack dab in the middle. See, in the figure, V is the number along the axis and is under the highest part of the curve. If it's under the highest part of the curve, it's the mean. All right, now, looks to me like it's all of them. In other words, it's 99.7, but let's just check. Because we need to have these values anyway. And we can use this neat little calculator. All right, so we got 170.8, and we're going to add 19.7 to it, and that's going to give us 190. So that's right around in here, not high enough. Let's add a second one. So that's 210, so that's right about right here. That's not enough. So it looks like it's going to be third, and that's what I was saying before. But let's add one more just so we can figure out what that value is. So 229.9, or it's right smack dab in the middle between 2020 and 2040, which is 230. So that's almost right on, but we're going to put the exact value there. Now, over here, we have to do the opposite. Remember, you're taking away. Notice it's getting smaller going in this direction. So let's start with the mean. Tell you what. Let's see, there's a... Put that in the store. Okay. So now, so I don't have to keep typing it in. 170.8 minus that is 51.50, in other words. Right around in there. So that's probably one standard deviation. Oh, that is one standard deviation. Let's subtract another one. So 2 is 131. So it would be almost right in the middle. So it's going to be one more. So 3 standard deviations down is 111.7. And you can see that 110 would be right in the middle between these two. It's just a little bit up, almost 112. So there we go. Questions about that?
Sir, Cruz, what number did you start to subtract from when you went backwards?
What do you mean when I start? What do you mean? What number did I said what?
Okay, so you see, okay,
See, there's
so
2 values up here. There's the mean,
yeah,
which is right here. That's the starting point.
so you
170.8.
subtracting 170.
No, this is the point right here. That's the one starting point right there.
Okay.
170.18. What I'm adding and subtracting is the standard deviation. Each one of these hops, each standard deviation is 19.7. So see, there's 1, 2, 3 standard deviations. Over here. 1, 2, 3. So that's how we found the endpoints. We're just adding 3 standard deviations. You can kind of also look at it like this. So we multiply it times 3. All right. All right. So that's 3 standard deviations right there, 59.7. See that? That was 3 times 19.7. I mean, if this were 20, it might make it a little bit more clear, but it's almost 20, and 3 times 20 would be 60, but it's just a tad under 20. So 3 times that gives us 59.1. All right. Now, let's start with that again. 170.8 plus, see, that's this one right here, 229.9. So I just added 3 standard deviations to the mean. Now let's do the same thing.
I see what you did now. Thank you.
That, and that's how we got that one, the 111.17. There's another one of these over here, number 12. All right. Oh, I thought that was. It might be a little further on up. I thought there was 2 of them, but it may just.
Can I randomly share something I realized about Alexis?
Mm-hmm.
So if you select the calculator and then highlight all of the numbers, it transfers them over, kind of like a copy and paste.
Oh, okay. Let's see.
Really,
but it doesn't.
You have to take out the commas then.
Yeah. Okay. Right.
Yeah.
You're right.
It might be useful for other people, so I wanted to share.
It does. That's true. But if you.
So yeah, I have to open the calculator first, and then highlight the numbers.
Does it not let me because I already answered the problem?
Maybe, I don't know.
But yeah, it'll put it in there. But yeah, then you got to change them.
Yeah, then it's easy for the addition part because then you take out the commas and put in plus signs.
Yeah,
but
because you don't.
I found it useful, so I was hoping
you're not having to worry about the mistakes because part of the problem is transcription. When you write it over, you don't see if you make. It's harder to see if you make a mistake, which is why I like copy and paste. All right, so now we're going to be doing the same thing, except now we're going to be just doing the same thing with z-values or standard deviation. A z-value is just the standard deviation, and these are not whole number ones. If we had whole number standard deviations, like 1 standard deviation and 2 standard deviations and 3 standard deviations, we could easily do that with the empirical rule. It might be a little bit of a pain in the neck, but you got 2 things you can use it with. You can use the table, and then you can use the calculator. I'll show you briefly on the table, but for all of them, I'm going to use the calculator. But I'm going to also use this little graphic over here. So to just show you, 0.85. This thing also. All right. All right. So 0.85 standard deviations would be just a little bit less than 1. So that's where this right here gets it pretty accurate, a lot better than I could draw it. All right. But we got to go back over and look at that question about what it asks. It asks for what is to the right of that value. All right. In other words, it wants to know. This is neat because you can see its complement real easy with this. So what we want is this. Now you're not going to have access to this with your lockdown browser ever. So I'm using it as a visual. And you can see from this 0.1977. So let's just try it now using both the book and the calculator. Now, if you use the table, it's going to be a little bit less accurate, but the book's not going to be worried about that. But the thing is, this table and that calculate there, they only calculate it one way. They calculate it what's to the left. That's the only way it's calculated. It's calculated as what's to the left. So in order to find out what's over here on the right, we got to use the complement rule. In other words, we're going to take this value that they're going to hand us, and then we're going to subtract it from 1. So we're going to find 0.85, which was this value here, and you can copy and paste this, thankfully. One minus, and that's what I showed you over there. Now, to just do it, I'll show you how you do it with the calculator. All right, there's this little thing right here. It's always going to do it from what's to the left, so you got to use the complement rule when you want to know what's to the right. So see that? It's the same value. It's more accurate, but when you round it off to 4, the 6 bumps this up to a 7, so 19.77. All right, questions about that? All right, I'm going to take a little break here to do that. So you got to deal with that craziness over there. Because one of the things I figured out, if I don't use the share screen total, I'll be talking and doing something on another screen and forget to share it. And then sometimes it's just slow doing it that way. Oh, and Danielle, can you hear me? I got a email with your certificate in it that you finished everything, and Alex, so that's great news. I'm proud to see that, because one of the things that I find is, people wonder, they get behind on that, and then they think that they can somehow magically do it at the very end, and it's just not realistic. You can probably do reasonably well by just using the practice tests in order to take the test, but nothing's going to prepare you. They're not going to prepare you as well, or at least not for most people. They're not going to prepare you as well as the learning path will. Because in all my classes, I got somebody, people that are behind, and they wonder, well, what can I do now? Well, get in there while there's still time and try to finish that. The longer you wait on it, the more time it's going to take, and you're going to have less time at the end to do it.
Yeah, Mr. Cruz, I had finished it. I was just trying to get over it quickly so I could just focus on your final and the last test we have to take.
And that's a real good idea. I'm proud of you for doing that. I mean, I've learned when I was in college that I don't do well if I procrastinate, because so one of the things I had to do to be successful was to start doing that, was to go make sure that I stood ahead of the curve. That didn't mean necessarily that I made an A, but it meant that I was successful in getting through. Because one of the things I think the students struggle with, and I did too, is you're smart, but most people are not going to be smart enough to just do everything in a day or two before the test, no matter how smart you are. if you're that smart, you probably should, would have tested out of this class. You know what I'm saying? I mean, and like I said, I had my trouble with plenty of classes that should have been easier. But like I said, I'm glad to see that. All right, and that's Raymond in here. Where'd Raymond go? He was here a minute ago. I heard him in there. I don't see. All right, so let's go back over. All right, so let's handle this one. Now, I want to go back to that little program that I got because I think this is good to just show you the visual. So what was it? I don't know if I can copy these. No, they don't let you do it. See, these they don't let you do it. I don't know why. I mean, I'm pretty sure it's to deal with what they consider cheating. All right. Now, that's the value we're looking for when we're looking for it for the between. All right. So we're doing it like this because our calculator is not this sophisticated, but we're going to look at first the larger one. In other words, the higher number, which is 0.73. Look that up first, generally. I mean, you don't have to look them up in order, but when you do your subtraction is going to come out as negative if you don't do it in that direction. And then what we're going to do is we're going to take off this little piece here, right there. And that'll give us the between. So that's what we're doing manually over here. So let's go back over here. All right. So there's a couple different ways to do it. I'm going to do it both ways. All right. Now, as I had said is, if you put the big one first, and then put the second one, you can stack them like this. So I'm going to write it in here. So it's rounded off to 4. So 1, 2, 3, 4. The 1 bumps up to a 2. All right. So let's go. I'm going to show you another way to do it to double check it. We can go back over and see it on here, but like I said, you don't have access to this for your test. So I'm just using that as a visual teaching tool. So what we're going to do is I'm going to do this one by itself. All right. So 0.763. I'll tell you what, I'll write it on the little board. And then the other one is now whenever you handwrite it out like this, it is, of course, going to be less accurate. Oh, let's see. Let me copy that and just do the other one again. Like I said, it's always a good idea to double check. And so see, you got the same thing, 0.7322. Because the between is not worried about so much. Well, it's only worried about what's in between those two values. So that's why we're subtracting the smaller one when we bring it back from the calculator, because we want to take that one off because it's not between, it's less than. All right, questions about this?
Mr. Cruz, do you think they would let us use the calculator on the test or no?
Well, it's right there. They can't stop you.
Okay. No, I thought it was only on the review.
I mean, you've taken tests before. Has it not been in there?
I'm talking about for that specific problem.
Well, it should be there.
Okay.
This is the practice test. This has got all of the same features as the test. Unless somebody knows different. I mean, this is exactly how the test ends up being. They don't put it on there on every problem. So let's see. Like this, I mean, that doesn't really do you any good here. So they don't put it there. They don't put it here because there's nothing really, there's no use to it here. There, no use to it. But look at that. For the mean, it's there. Even if you had the median, see, well, this one says median, no, they still got it there. Even though it's not going to do any good for the median, it'll do you good for the mean. So see, as far as I can tell, it's always there when you need it for the range. Even though that's a very basic, simple calculation, highest minus lowest, it's there. See there? I mean, to me, the standard deviation calculator doesn't help too much because you're having to do it by steps. It's still there. It's still there. Still there. So I think it's always there. If somebody knows different, I don't think there's any problem with that. All right. So yeah, this is the one I was saying is, now this is the, yeah, it's the same thing as that one where they had the visual. And then we got another one that uses a table. We got to calculate the z-values. And there's two of those. Okay. All right. So all right. So what we've got a mean, and we've got a standard deviation. So what I'm going to do is I'm going to take 8, 110, because that's the middle, the mean, and I'm going to add a standard deviation to it. I get to 900. Well, it's not quite high enough, so I'll add another one. So we get to 990. Still not high enough. Add another 90. And then I get that number right there. So that's 3 standard deviations on the right up. Now, I would almost bet, because it's a between problem here, that if you do the down, we're going to put this here here, it's that one. But let's just double check it. Let's do the... So let's take 8110 minus 90. Wait, what happened? 810 minus, so 720. So that's not quite low enough. So let's subtract again. Not quite low enough. So let's see if one more will do it. 540. So this right here is 3 standard deviations down from the mean, 3 standard deviations upstream from the mean. So that's 99.7. That's 3 standard deviations. Now they ask us, what are the values or the borderline points for, or the margins for 95%? Well, what is 2 standard deviations? 2 standard deviations relates to 95. So 90 times 2 is 180. So I'm going to add that. And that'll be the upper boundary. And then I'm going to subtract it. And we saw that number pop up before when we were subtracting 90. We got down to that there, and when we did one more on each side. So that's 2 standard deviations for our 95%. Okay, so questions about that? This is kind of a word problem. It's really the same thing as what was in number 10 for the most part. It just doesn't have a visual for you. Same thing. All right, so let's just do these last 2. These are both what we would call applications. Now, the only thing that we're going to have to do, though, is we're going to have to calculate a z-score, because the one thing that's different here is there is no z-score. You know, when we were working on that problem where I showed you, look up in the table, we had a less than, a greater than, and in between. We had the z-scores handed to us. Here, we don't. We got to calculate those z-scores. So I'm going to write the formula over there to remind you. So here's the z-score formula. So in the numerator, it's the difference between the value you're calculating for and the mean. The value you're calculating for always has to come first. And then down here is your standard deviation. So what you have to do is you take the difference. It's going to be either positive or negative, depending on whether the mean is larger or smaller. And then we're going to divide by the standard deviation to give us that value. All right. So we're given the values that we need here. We got the mean, we got the standard deviation, and then this is what we're calculating for. And we want longer So that's going to be the complement. We're going to figure out the z-value and then subtract from 1. So z is equal to 634 minus 620 So calculator time. You don't need to do write it down. I'm just wanting to try to explain it and show it because you can easily do this. You still got to type it in. I don't know why it didn't work here, but it worked on that other one. I don't know why I don't know how you just correct one mistake. I was just off by. All right. So there's 14 difference, and then we got to divide by 25. All right. I'll do it over here, rest on the board. So this is going to be negative 14. So, whoops, what happened? Must put in a decimal. So negative 0.56. So that was right. All right. So we got to use the complement rule because that's what that means right there. All right. So because what's going to come back from the calculator or the table is less than. So let me just write this out real quick. Oops. So what we're going to do is we're going to take that and put it in the calculator, and then we're going to do. All right, so let's go back over there and use that calculator. All right, so put it in there for me. So 0.2877. Now you got to watch this. All right, I'm going to use the calculator, and so it's going to be 0.7122. I'm knocking off the negative sign just to save time. All right, now we got to go over. Remember, That's 71. Okay? So pay attention to whether it's less than or greater than. This is definitely greater than because it's longer. And this was probably going to be a between. The between. Now, we got two Z values to figure out. We got 175 and we got 186, but we still got the same mean and standard deviation for both of them. So we're using that same formula. Well, we're going to have two Z-scores. And just like the problem two back, we find the between by subtracting smallest from the largest. So I'm going to call the larger one Z1. This is the larger one. So here's our mean, and there's our standard deviation. All right, so let's use the calculator and do it. And like I said, at some point you're going to have to write these down, especially for the between. And it probably would be a benefit for the greater. Usually for the less than, you can just do it on the calculator and look it up. It may even put it in for you. I don't know. Let's see what we can do. We got 187 take away 154. And you can have it do it all in one shot for you like this. You got to use the parentheses because it's got to divide both of those. So 2.2. So I'm just going to kind of do it another way here. Let's see. So 187 minus, and then divided by 15. So 2.2 is correct. So I'm going to do the other one real quick because it'd be better just to go ahead and do them. The same operation. Do this part first, plot for both of them. And then we can just look both of them up. All right, so the case 1.4. Just try it one more time, a different way, because I like to make sure I'm correct. So 1.4. All right, so I got to look both of those out, and then I'm gonna. All right, so I'm gonna look up this one first, 2.2. So it does put it in there for you. I'm not sure. So then 0.9, and that's going to be a bump up to a 1. So that said, you got to do it by hand. You got to round it. So that 9's bumping it up to a 1. All right, and then this one, what was it? It was 1.4. So these are both large, but it's still gonna. All right, so let's do it on the calculator all in one swoop, and then we'll write it in too. So in order to do it by between, I want to put the larger one first, which was 2.2, and I'm going to have this page open. There we got it. So that's going to bump up to 9 right there for 4 decimal places. All right, so that's the value we're going to put in there. It's going to be accurate to 4. All right, so that's pretty much it, folks. So we got to bump that. It's go over 2 spaces, so 0.0, so 6.68. All right, any final questions? Y'all can let me know Tuesday if you want to try to have a review day next week. The week after Thanksgiving. But make sure you get this last test in, and make sure you do well on it, because you don't want to put it off and have to rely too much on the exam. All right. This thing is ending and at the last minute before a break begins. In other words, break begins on Wednesday next week. So at the stroke of midnight, right after the test ends, the break begins. So when we come back, there won't be any more classes. That's the last day of classes for you folks. Okay. I will try to. I'm sorry. Monday is. So there's that one day Tuesday, but that's the last. That Tuesday is the last day, and that should be geared towards the final exam next Tuesday. All right. So I'll stick around here for a few minutes.